Hey all dear friends, let's see this question of 3-block problem from HCV. As you can see in the screen, there are 3 blocks 2 kg, 3 kg and 7 kg placed one over other on a horizontal surface. The coefficient of friction between them are given. Between 2 kg and 3 kg it is given to be 0.2. Between 3 kg and 7 kg the coefficient of friction is 0.3, and there is no friction between 7 kg and the horizontal surface. Now a horizontal force of 10 Newton is applied on first block of 2 kg, then block of 3 kg and then block 7 kg. We have to find the accelerations A1, A2, A3 of the all 3 blocks in all the 3 cases, and we have to take G is equal to 10 meter per second square as we normally take. So first thing that I'll do is to find the friction between the pair of the bodies. So between 2 kg and 3 kg, normal reaction is the weight above 3 kg, that is 20 Newton. Coefficient of friction is 0.2, so maximum available friction is 0.2 into 20, that is 4 Newton. So friction will act according to the requirement. So static friction would be anything between 0 to 4 depending on the requirement. And if kinetic friction will act, because there is only one mu is given, so I would mean that the mu k and mu s are the same. So if kinetic friction between 2 kg and 3 kg will act, so that will be 4 Newton. Now same way, between 3 kg and 7 kg, the normal reaction between them is a total weight above 7 kg, that is a 50 Newton. Coefficient of friction is 0.3. So maximum available friction is 0.3 into 50, so that is a 50 Newton. So friction again here could be anything between 0 to 50 Newton depending on the requirement, and there is obviously no friction between 7 kg and ground because there is friction coefficient is 0. So now in the case 1, the 10 kg Newton force is applied on block 2 kg. So let's see that. So let me assume that this whole system moves with a common acceleration, say A, as we normally assume in a 2 block or 3 block problem. So I'm assuming that, I'm not writing, just stating that. Let me assume that the whole system is moving with a common acceleration, say A. So magnitude of the common acceleration would be the total force divided by net force divided by net total mass. Net force is 10 Newton and total mass of the system is 7 plus 3 plus 2, that is 12 kg. And obviously there is no friction from the ground, so 10 Newton is the net force. So the common acceleration, if they move with this common acceleration, would be 5 by 6 meter per second square. Now we'll take 2 blocks at one time as a system. So we want to take 3 kg and 7 kg as a one system. Since this whole system is moving with a common acceleration A is equal to 5 by 6, so that what we assume, so this part should also move with the acceleration 5 by 6 meter per second square. There is no force from the ground. So the only force that can move this system of 3 kg plus 7 kg is the friction between 2 kg and 3 kg, that the static friction. So let me assume the static friction between 2 kg and 3 kg is, say, Fs, and then this Fs must be total mass, that is a 10 into common acceleration, that is a 5 by 6. Whereas 50 by 6, that is a more than 8 Newton, and you can see there the available friction between 2 kg and 3 kg is 4 Newton only, and the requirement is more than 8 Newton. So it means there is a slipping between 2 kg and 3 kg. So our original supposition that all 3 blocks are moving with the same acceleration has proved wrong. So one thing is clear, there is slipping between 2 kg and 3 kg. So kinetic friction will act. Now we have to inquire, we have to investigate whether there is a slipping between 3 kg and 7 kg or not. So once again, I will assume that let's 3 kg and 7 kg are now moving with the same acceleration. This is clear that 2 kg and 3 kg are not moving together, but we have to see whether 3 kg and 7 kg are also moving with together or not. So for that thing, first let me assume that 3 kg and 7 kg are moving together. So now it was decided that there is a slipping between 2 kg and 3 kg, so friction on 3 kg would be 4 Newton. So on the system, the net force is the kinetic friction on 3 kg by 2 kg block, that is a 4 Newton. So magnitude of common acceleration is say A, and that would be 4 by 10, mean 0.4 meter per second square. And now I will take a system of 7 kg alone. So if I take a system of 7 kg alone, if they are moving together with a 0.4 meter per second square, so this 7 kg will also have the acceleration 0.4 meter per second square, and for it to move with this acceleration, the required friction would be Fs would be 7 into 0.4, so that is how much, 2.8 Newton, and the available friction between uh, 3 kg and 7 kg is 50 Newton, requirement is 2.8, so our supposition is correct. So 3 kg and 7 kg are moving together with this acceleration. So this is acceleration of 3 kg and acceleration of 7 kg, that is a 0.4. Now we had to find the acceleration of the 2 kg block also, and it was decided that it is moving with a there is a slipping between 2 kg and 3 kg, so there will be kinetic friction. Oh, let me draw the FBD of 2 kg also. So this is the FBD of 2 kg block. There was a force, this 10 Newton, and the coefficient of friction between them, sorry, the friction force between them was 4 Newton, between them in between 2 kg and 3 kg was 4 Newton. So acceleration of 2 kg block A2 is 10 minus 4 is 6, and 6 by 2 is 3 meter per second square. And now we have to apply force on the middle block. So suppose if 10 Newton force is applied on the middle block, same way let me assume that this whole system is moving with a common acceleration. So the same way, common acceleration would be the net force upon total mass. The force is same, only the block has changed, masses are same. So common acceleration would be again 5 by 6 meter per second square. So what I will do, I will take a system of first 2 kg and we'll see whether slipping between 2 kg and 3 kg is taking place or not. So if I take a system of 2 kg only, so in 2 kg, if whole system is moving with this acceleration, so this also has to move with the same acceleration. And who can give this acceleration? Obviously the friction force between 2 kg and 3 kg can provide this friction to 2 kg block. So friction force on 2 kg block should act on the forward direction like this. So that friction would be mass into acceleration, so that is 10 by 6. 10 by 6 is less than 2, so less than 2 mean available is 4 and requirement is less than 2, so that is very well they can move together. So 2 and 3 can move together. And same way we'll check for the 7 kg block. So for 7 kg block, the same way, if it has moved with the same acceleration 5 by 6, so the required friction would be Fs here would be 7 into 5 by 6, that is 35 by 6, less than 6, available is 15. So here also the 7 kg can very well move with the 3 kg block. So all three blocks in this case will move with the same acceleration. So our supposition that all three are moving together is correct. So in this case A3, A2 and A7 is all equal to 5 by 6 meter per second square. Now the last case, in which the force is applied to the bottommost block, that is a 7 kg. Same way, assume that all are moving with a common acceleration, say A. So common acceleration magnitude is 5 by 6 meter per second square. Now what we'll do, I'll take in this case a system of 2 kg and 3 kg, and we'll see first whether there is slipping between 3 kg and 7 kg or not. So as whole system is moving with the acceleration 5 by 6, that's what we assume. So this part should also move with the same acceleration. And the force that can provide this acceleration is the friction between 3 kg and 7 kg. So required friction should be that Fs should be the total mass is 5 and acceleration 5 by 6. So 25 by 6, 25 by 6 is around 4, and available is 15. So that is clear that there is no slipping between 3 kg and 7 kg. The required friction is less than available. And finally, I can see whether this 2 kg is moving with the same acceleration or not. So let me draw the FBD of 2 kg. If I take a system of 2 kg, and actually this we had checked in the part B, but still again I am checking. This is a 5 by 6 acceleration. So required friction would be Fs would be 2 into 5 by 6. So 10 by 6 less than 2, available is 4. So here also there is no slipping between 2 kg and 3 kg, and there is no slipping between 3 kg and 7 kg. So there is no slipping between either block. So all the three block will move with the same common acceleration. So magnitude of acceleration in this case would be same. A2 is equal to A3 is equal to A7, and that will be 5 by 6 meter per second square. So essentially a 3 block problem is nothing but a 2 block problem only. At a time, initially you can assume that the all bodies are moving with the same common acceleration. Then you can take a pair of two bodies at a time, and inquire whether the slipping between two surfaces taking place or not, and this way you can proceed.